this crazy thing called slope. What was slope? Up and over stuff. What do you mean up and over stuff? Louder? Rise over run. Okay. The slope, you guys, most of you guys have defined it in the past as slopes in the past as your rise over run. Now, when you're in a two-dimensional graphic or two-dimensional plane, where you graph things, your XY coordinate system, what values rise? The X's or the Y's? Y's, yes. Trust yourselves. The Y values are what rise. Up and down goes Y, left and right then goes X. So that means, and I don't know if you've ever written it like this before, the change in Y over the change in X. You guys ever seen that with the triangle? Well, the triangle shows that triangle is the Greek letter delta, and that represents, in terms of math, change. Change in Y over change in X. And in order to figure this out, though, how many ordered pairs do you have to determine the slope? How many? Not really. 2. All you need is 2, because how many points do you need to make a line? Well, you need 2, and then you can use those same 2 points to figure out the slope. So that's how that works. Nope. You don't need the third one. You can have it, but it should be the same slope between all 3 of those points. Should have the same slope in relation to each other, because if they're on the same line, they should all have the same slope. So what we do here is we have 2 sets of what are called ordered pairs. And I know you guys have all seen this before. And the reason why we use these little, they're called subscripts, x sub 1, y sub 1, x sub 2, y sub 2, that just means first set of ordered pairs, second set of ordered pairs. If there's a third set of e sub 3, and so on and so on. Do you remember what letter we used to show slope? No. You're getting into equations of lines, but you're almost there. What letter do we use for slope? Think about the equations of lines. M. You had mx, like you're almost there. M. Hey, do you know why they use the letter M? No. Think about the alphabet. What are letters A, B, and C used for in math, especially geometry? Triangles, but Pythagorean theorem. A squared, B squared, C squared. We use that a lot. What is D used for in math? Distance, diameter. Okay. E is an exponential function. Principal, interest rates, things like that. F, G, and H. These guys are used all the time as what's called function notation. You may or may not have seen f of x, g of x. What that means, it's, things like this. That's function notation. They use f, g, and h all the time for that. Do you know what I is for? Nope. I scream, you scream, we all scream for ice cream, but that is wrong. Sorry. It's imaginary numbers. Yes, there are numbers that you don't know that really exist, that don't exist, but they do exist because they're imaginary. No. J and K, there's a thing called direct. You may have done this last year. There's a thing called direct variation. It was a precursor to learning about what the slope was. It would say like x and y vary directly with some constant k. They use what's called direct variation, and then in algebra 2 we talk about a thing called a joint variation, which means there is multiple parts that multiply together to create some slope-ish thingy. So that's why those are used. L, lines, but what does that look like all the time? A 1, it looks like that. But so then they got down the alphabet, they got to M. They're like, oh, well, we really haven't used that yet. And like, I forget who it was that asked me, I don't know if it was this class or not, but, oh no, it was algebra 2 class. When we were talking about imaginary numbers, the reason why that came about was because you had to be able to solve for a problem, but you couldn't take the square root of a negative, so they had to come up with a way of doing it. like, well, if we just call it imaginary, they're like, oh yeah, that works. Yes, sir.
Square root of negative 1.
Can you take imaginary number is the square root of negative 1. Think about this. When you take a square root, for example, what is the square root of 36? 6, or negative 6. Square root means what are two numbers that are exactly the same that you multiply together to get you 36? Well, 6 times 6, or negative 6 times negative 6. There are no two numbers that multiply together that are the same to get you negative value, because they have to both be positive or negative. So what happens is, in math, you may have seen this before, where you got down to x squared equals negative 12, you would just say no solution, because you couldn't take the square root of negative. You really can't. Because you can take an imaginary number. Obviously, this is nothing you'll deal with this year, you'll deal with it next year. Real world application stuff of this, the reason why imaginary numbers really came about is resistance between electric, I think it's ohms, I want to say. In order for transistors or something, the way that current works, it has to move back and it has to have a negative value. So they had to come up with something to make it work. Math is gonna math. But yeah, this M thing, they just basically went down the line of the alphabet trying to say, oh, we haven't used this yet, because they did that because then they started with other things. Z is, there's a Z testing in statistics. So there is a way that you can bounce values for standard deviation. It's called, let's see, it's not a Z-score, it's a Z. There's something in math in a stats class that deals a lot with calculus that you use Z values for. You never know. Anyway, so slope, change in Y, or the change in X. Oh, and by the way, this whole M thing, yeah, that was all made up. It starts from the Greek letter modulus for change.
Wait.
80-20, guys. You gotta try to figure out which one's which. That was a 20.
Now I'm not sure. That was
No, it's imaginary. It's not real. I know where you're going with it, but yeah. Yes, sir. Maybe, maybe not. That's in the day. See how I feel. Yeah, right? There are, guys, there are 4 types of slopes. There are 4 types of slopes. Again, this is something that all of you know. This is nothing crazy. What is one type of slope? Positive. Okay? So, see if we can figure this out. There's a positive slope, which means that there has to be a negative slope, okay? Which means what's exactly halfway between all positive and negative numbers? Means there is a zero slope. And then last but not least, what is it? Very good. There's an undefined slope. Yeah, I'm going to show you an example. So, when we're dealing with these slopes, if it's positive, what direction is your line going? Up and right. I see where you're going with it, but it's going up and right. Are we okay with that? Yeah. So, positive slopes go up and right. What's the opposite of up and right? Very good. The reason why we say that is sometimes when you're graphing things, depending upon what the slope may be, you might run out of space sometimes by going up and right. So you might have to go down and left to show the line. So up and right or down and left. This is a no BS reason why, but this is 80% why this is true. In the first quadrant, X and Y are both what? Positive. In the second quadrant, they are, and then positive, negative. Now, slope is the change in Y over the change in X. So slope is basically Y over X. So if you're going positive, when I'm in this quadrant, I have a positive divided by a positive, which is, in the quadrant down here then, I have a negative divided by a negative, which is a positive. That's why this works. Okay? That's why that works. Then by the other method, if you turn your head the other way around, you go the other direction, that's where you get your negatives. So if I'm up and right positive, that means I am negative going down and right. Down and left. If I go down and left, I'm going down and right is negative. The way that we show this is because I always like to go first step. If your first step is positive, you go up and always go to your right. If the first step is negative, you go down and then always go to your right. That's the easy way. That's the way that I've always taught it. It's the way that I've always thought of it. That way you don't have to try to mix up which one's positive, which one's negative. If it's a positive slope, you always go up right. If it's negative, you always go down right. So, like I said earlier, if down and right is the same thing as going up and left. And like I said, most of today's stuff is all reviews. Zero slope. What kind of lines, don't say straight, have a slope of 0? Horizontal, very good. Horizontal lines have a slope of 0. What's the second letter in the word horizontal? O. That O looks like a 0. Whoa! It's crazy. Now, the reason why that works is because when you have a horizontal line, your Y value never changes. Your X value changes. So if your Y value never changes, you get your slope is 0 divided by some number for X. Okay, that's why that works. Also, what's the equation then of every single horizontal line? XY equals 0? No. If X equals 0, it would be at 0 and it's always 0 vertically. Y always equals a number. Because if Y equals a number, you think about it, obviously you don't have a graph, don't worry about this. If I say Y equals 3, where does Y equal 3? Well, it equals 3 here, 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 here. And so on. Okay. That Y value, as you go through it, just that Y value, it always stays the same. That's why that looks like that. So by process of elimination, if horizontal lines go left and right and have a slope of 0, what kind of lines do you think have a vertical or what kind of lines have a undefined slope? Boy, man, you guys are smart. SMRT. So the reason why the vertical line has an undefined slope is because the value never changes. So if the x value is always the same, what's the same number subtract the same number? So that means what happens is you get 0 in your denominator with some number in for the numerator. Can you divide by 0? No. That's why it's undefined. Okay? Undefined is when you have 0 in the denominator. 0 is when you have 0 in the numerator. And then therefore, if y equals a number, goes left and right, x equals a number, goes up and down. Okay? Again, this should be all review, hopefully-ish. Okay. So back to the idea of how do you find said slope? Well, first of all, you need a set of ordered pairs. And to be honest with you, the first couple times that I do this, I always label them. And I always write out my equation. My slope is the change in y over the change in x. Again, the reason why I say x sub 1, y sub 1, x sub 2, y sub 2, I'm just putting them in numerical order as I see them. First set of ordered pairs, second set of ordered pairs. Just to keep them straight. Yes, sir. The way that they do this is because you, in order to denote change, you go far subtract plus. That's just how they always show change in math. One of the rules. I always go first set of ordered pairs for x and y sub 1s, second set of x and y sub 2s. I just go on the way that I see it going from left to right. I always thought that was the easiest way to not mess them up. And then it's just a matter of piecing it together. What's nice about that multi-view calculator is that you should never get anything like this wrong. 2 minus a negative 6 divided by 7 minus 4. The calculator itself, if you use subtraction buttons and the negative symbols with the fraction bar, will always simplify it for you. Or if you want to crank it out by hand, that's fine as well. We get 8 over 3, and you're done. That's the slope. Again, I think I've said this with you guys before. No mixed numbers. Okay? You can't walk the slope of 2 2/3, but you can walk the slope of 8 over 3. Mixed numbers are stupid. I don't say that about a lot of things, but mixed numbers are dumb. There's only like one other time in your high school mathematical career that you will ever want to use one. Other than that, when you're counting degrees of pi for radians value. It's not tough. It really isn't. Just counting revolutions. Revolution is around an object. Just counting how many times you go around. It's easy. Not bad. We don't need to do another, do we? So let's talk about then the next bit. Writing equations. In geometry, we tend to use just one method for writing the equations, and that's always pretty much going to wind up being slope-intercept form. Reason why we like to get you guys to use slope-intercept form is because when you have well, first of all, you guys remember what slope-intercept form was? I'm going to have myself here. A CFC? No, that's not it, but it's close. Más o menos. What is it? Perfect. Slope-intercept form was that y equals mx plus b. This is something that you guys used a ton of last year, where that value of m represents its what? Slope. What's that? We're not there yet. And the b value is your... No. Think of the word slope-intercept form, so the b value is the where though, x or y? It's your y-intercept. So just for funny, if I say that I have an equation y equals 2x minus 3, and I'm just kind of rough sketching this real quick so you remember where you would always start these things. What's the y-intercept of that graph? -3. Very good. So that means on the y-axis, this line hits it at -3. And then I would walk my slope, which is 2. Is it positive or negative? So what direction do I go first? Up 2, then what direction? Whoa. Right, how many? 1. What's 2 divided by 1? You can put 1, any number can be divided by 1 and it doesn't change. So anytime you have a whole number, whether it's positive or an integer, 2, -2, 3, -3, whatever, same thing saying 2, it's the same thing as 2 over 1. I just made it. They don't put it there. Not every number is going to be fraction form. You can have a slope of 2, that means your change in y is 2, change in x is 1. Remember, no, don't overthink it. 2 is the exact same thing as saying 2 divided by 1. They mean the same. It's just like when you have a coefficient. What's the coefficient from the x that you don't see? It's a 1. You can put 1s anywhere and it doesn't change it when you're dividing or multiplying by value. Yes. Yep. So all you would do is go up 2, right 1, up 2, right 1, and you can go something like that. That's what that looked like when you did it. So what happened was sometimes you were given information. Let's say you had a slope of -2/3 and a y-intercept of 4, and I asked you to write the equation. If you have a slope of -2/3 and a y-intercept of 4, what's your equation? Yeah. When you're given this info, and you can tell by most of you guys just kind of like, oh yeah, I remember this. You're just filling in the blanks. Your slope is that -2/3, and then you tack on the +4. And that's all you had to do. Okay? But of course, math was never that simple. A lot of times they gave you a point and some slope to work with, which meant you had to work with a different form of equation. What happens if I ask you to write the equation with a slope of 3, and it goes to the ordered pair -2 and 1? What did you do then? Remember that? Well, what information have I given you there? Slope and a point. Remember that thing called point slope? Vaguely? So there was this thing that you used last year. It's called point slope form. Where it literally works with a point and a slope. And it looked like this. That point slope form of an equation allowed you to take any slope at any given point, substitute in some values, and then rewrite it into slope-intercept form by doing a couple of distributive property, or doing the distributive property and adding whatever your y value was, or some for y. This was, for lack of better terms, a working man's version of slope-intercept. It was just a format to which you can just substitute in values and go. Because if you look at the idea that you have a slope and a point, or a point slope here, you've got your slope, you've got your ordered pair to work with. You know those three things. All you're doing is substituting in those values and getting y by itself. You're like, what's this witchcraft? It's been a while since you've seen it. We just kind of bum rush through a couple of it, and it takes time to work through it. So you wind up with y minus 1. Oh, I know. I forgot to ask you this. When you have minus and negative, what does that become? Yeah, it becomes positive. Minus and negative, we always rewrite as plus. So you get this idea of using this thing called point slope form. Point slope form is the format that we use a lot over the course of the next, I don't know, 3 or 4 days when we're writing equations of lines a lot of times, because we're going to know slopes, we're going to know points. We're going to have to write equations of lines that are parallel through a given point, perpendicular through a given point, and we're going to keep reusing point slope form. So if I substitute in, I got to get y by itself, which means I got to distribute. I will recommend that you draw those arrows, especially the first few times. It's been a while since you've done it. That way you remember to send that value up front to both parts, because that's what people forget from time to time. Oh, excuse me. And then what would I do with that one? Add it, very good. Add that over, very good. Very good, gentlemen. So the equation of the line that contains that slope and that point in slope-intercept form looks like that. Now, I know some of you may have learned a different way of doing that by just writing out slope-intercept form and solving for the intercept. That's fine, but I would suggest using this one because as we get into writing parallels and perpendiculars next week, it's a lot easier to use this format because that's kind of how most textbooks and things use it, just so you remember. Yes, sir. Write the equation of a line that contains the point through this with this given slope. Well, don't worry, we're gonna do another one, okay? No worries, man. Seriously, it's been a while since you've seen it. I'm just kind of getting these equations out in front of us for right now, and then we're gonna continue on. So let's see, we have slope was change in y over the change in x. Slope-intercept was y equals mx plus b. Then point slope was y minus y sub 1. Okay, that's kind of what we're looking at from today. Show you another one. Excuse me. Slope negative 1/2 through the point 4 and negative 3. We'll write the equation into slope-intercept form that goes through that point with that slope of negative 1/2. Okay. So if I have a slope and a point, that means I'm going to use point slope form because that's what it's called. So I write it down. Okay. Fill in the blanks. What's my y sub 1 coordinate? Negative 3. So when I substitute in, it'll be y minus the negative 3 becomes y plus 3. I think that's where you're getting at for 3. Yeah, because it's a negative. So if I write minus a negative 3, that just becomes y plus 3. But for anything, anytime you're writing minus a negative, you just automatically switch to plus. Or write it out and then remember, oh, that's what I'm doing. And that's fine. I was just shortcutting it out. So then you have your here, our slope, negative 1/2 times x minus 4. No, you've got, because that's the ordered pair you're given. That's the x sub 1, y sub 1. Okay. So now from here you would distribute and get y by itself. Yes, ma'am. Correct. Correct. If it was a minus 4 to start with, it would be minus a negative, and that's where it becomes plus. So when I distribute in, you get negative 1/2 x. What's negative 1/2 times negative 4? Very good. 2. And then lastly, how do I move that 3? Subtract it over. Because you want to get y by itself. You're trying to get it into slope-intercept form, which has y by itself. Okay? What's that? Yes, sir. The equation of the line in slope-intercept form is y equals -1/2 x minus 1. Okay. Now, the only other weird thing that can happen for right now for today is if you're just given a set of ordered pairs. Sometimes if you're given just a set of ordered pairs, you have to then find the slope and then write it down. So it just makes you have to do one extra thing. Okay? Let me show you an example of that. Let's say you have 2 ordered pairs, 2 and 4, and make this 1 and 6. And I'm going to write the equation of the line that contains those 2 points. That's kind of the way that it would be worded. So if you have to do that, the very first thing you're always going to do, is find slope. Okay? First thing I do when I'm given a set of ordered pairs is find their slope. Changing y, 6 minus 4, or changing x, 1 minus 2. You can throw that whole thing in the calculator with the fraction bar and press enter, or you can break it into 2 small parts. What's 6 minus 4? 2. What's 1 minus 2? -1. That makes my slope 2 over -1, which most people will rewrite as -2. Very good. And that's where the whole idea of over 1 comes into play. It means the same. Now I have my slope. So the second thing I do, or basically the last thing, is use point slope and solve for y. Okay? Because I have my slope, and all I have to do is pick one of the points. I can pick either one of them. It doesn't matter. It's totally up to you just to say, hey, I feel like using the first one, or hey, I feel like using the second one. It doesn't matter. Sometimes one of them will have a 0 in it. If that's the case, it's a little bit easier to work with things with zeros, less math. But the point slope then, remember you have y minus y sub 1. Just using that. So you want to use the first ordered pair or the second ordered pair? Well, remember, if you did this earlier and you labeled them, if you already labeled them to get your slope, why not just use the first ones that you use x sub 1? That way you already know what they are. See where I'm going with that? Already labeled. You got a slope, you got that, so you fill in the blanks. Y minus 4 is -2, x minus 2. Distribute the -2 for the slope. Get -2x. -2 times -2 is positive 4. Very good. And then I have to move that -4 over. Y equals -2x plus 8. Now, I know that's a lot right here, but remember, a lot of this is, we're going to be doing this for basically the next 3 or 4 days, whether it's finding slopes, writing equations of lines. Eventually, maybe tomorrow we should be able to get into a little bit of the graphing of them as well. Next week we'll be still writing equations of lines that are parallel. My best guess is that we'll probably be testing on this stuff. I'm gonna say probably Thursday at the earliest, Friday at the latest. My guess would probably be Thursday. Wait, I'm looking at how many days we have of these things. Okay, so it's this what we did. We're doing today, tomorrow, Monday, and Tuesday. For basically 4 days worth of stuff here. Is a lot of review from what you did in your linear things in your Algebra 1 classes. Now I know this is geometry, but you're reusing a lot of stuff that you did in algebra. This is the one section that it comes back to. Okay. I think I don't know if I posted it. I have I posted a couple on the textbook. I have you guys on page 194, numbers 13 through 15. It's just find slopes. And then 24 evens. Yes, sir. So I've got 3 of them that are find slopes, and the other 5 are write the equation. Okay. So 13, 14, and 15 is just find the slope. The other 5 are write the equations of the line that contain, a slope and a y-intercept, 2 points, or a slope and a point. So you have to do that stuff. What's up? Okay. This one is this one is slope intercept one. Okay. That's if you have a slope and an intercept right off the bat. Where this is your slope, B is your y-intercept. Okay. Here is when you have a point and a slope. Kind of, yes. I used point slope to get to slope intercept. Because we can put all of our answers into slope intercept given, because here if you're only given the ordered pair, 2 ordered pairs, what can you find? Slope. Once I have slope, I can use a point like this to get me to here. No, we're getting to the y-intercept. We're finding that if y-intercept is at 8. The y-intercept is at b value. Did you learn the form where you would just use y equals mx plus b, substitute in those 3, figure out your y-intercept? There's a couple ways of doing it. It should be the same. What do you mean? Oh. What do you mean? Okay. Oh, I see what you're saying. All right. What's happening is these are ordered pairs. We're trying to figure out the equation of the line that contains those ordered pairs. Yeah. Well, that gives you the slope part. Because what you're doing here, with those 2 ordered pairs, if you think of it, those are those 2 ordered pairs. You're trying to figure out what's the equation of the line that contains them. So we're trying to figure out what line has those 2 points. Lines are always written in the format y equals mx plus b. We know that between those 2 points, we figured out that the slope was -2. Then we knew that if I used one of those ordered pairs, 2 and 4, I do y minus 4 is our slope, x minus 2. If I manipulate that equation, I will get it into this format. Or where? Oh, I'm sorry. Now I see what you're saying. Okay. These values here are getting you to these values here. No, that doesn't work. Because then you'd have you have 6 minus 4 equals -2. Then you'd have 6 minus 4 is 2. Then you'd have, the other one would be 1 minus 2 is -2 times -2 is 4. 2 doesn't equal 4. This x and y value, this x here and this, I'm sorry, that y and this x, these two values tell you when you have an equation that's linear. That's first degree linear equation that goes into the xy coordinate system. It has nothing to do with that second order derivative. Thanks, guys. Yeah. You substitute into that point slope form, and you can use either ordered pair. It doesn't matter. Yes, -2x, yeah. Yes, sir. Yes, sir. If you did both of them, you're going to get the same equation. Because you should, because those points are on the same line. Yeah. There's like 5 of them. That's what computer does. I don't have to change like way too much. I'm sorry. Yeah. It's just, we only gave you just 5 of those.